Alan Hooper with Southwire Company. Today we're going to demonstrate on how to use the Southwire SIMpull Cable Pull Calculator that's on our website, and we're going to go over the Excel file. There's also an app, so if you want to call us, we'll explain that as well. But to start off with, when you go to Southwire's website at southwire.com, this will be your home screen, and in the search box, just type in the word calculator. Hit search, and up pops the SIMpull Cable Pull Calculator right here. When you double click it and download it, you want to get the most current version, which is 5.3. Occasionally we do enhancements, and that's why we continue to update the version number. If you have an old calculator, though, I can assure you the formulas will give you the same result. We just have extra enhancements. So when you go to download this, you want to be sure to save it to your laptop, and we've already done that. So we'll go right to the calculator that is saved. First thing you want to do, make sure you do, is enable macros. Once you enable macros, you will be ready to operate the file. So what we have here, we're going to change the view for your purposes here. We're going to go to 150% view. So basically this is the first top of the sheet of the Excel file. When we go down the sheet, we have what we're going to use for pulling information, okay? And on this particular sheet, we're on the calc for 600 volt. You can see the bottom left here. There's also a calculator for calc for power cable products. So there are, if you right click on any of these tabs and you hit unhide, you'll see all of these sheets or formulas running in the background. Nothing is hidden as far as formulas. I'm going to click OK. So we don't need to see, cancel rather. So nothing is hidden on these formulas. If you want to check anything out, you can, but everything is protected in certain cells, so you can't change the results of the formulas. So this is the sheet, and I'm going to explain the sections that we have. The first part is wire information that we need to load into the sheet, and I'm going to pick a number of wires. Everything in purple is mandatory. Everything is yellow is optional. When you have yellow things that automatically populate, that is the default. You can always change that. All right. So we're going to click on that first tab here in B7, and we're going to number of phase wires. We're going to have 3. We're going to choose copper THHN as the default. Although I have all these other choices, copper XHHW, copper USE, SIMpull aluminum THHN, aluminum X, aluminum USE. But the default is always THHN, and I'm going to pick my wire size, and for this particular case right here, we're going to pick size 500. And immediately populates the OD of the cable and the weight per foot. Like I say, if you're not using a Southwire product, you can change those features because everything is based on cable weight and OD. All right. So once I do that, we have the calculator up and running. And you'll notice in the middle of the calculator, I'll always show you what version you're on. And when I start clicking through here, you're going to see, this is, like I say, this is for 3 phases right here. We're going to pick a neutral wire of 500 again. I could have clicked on 4 phase wires, but we'll just keep this looking good. Right here is a handy ground wire sizing drop-down box per the NEC code 250.122. For voltage drop considerations, you might want to go to a larger size. But this right here, say I want to know what size ground wire needed for 800 amps. It's going to tell me a 1/0 copper or 3/0 aluminum. This is your ground wire sizing NEC for 250.66 for service entrance. Okay, so this is just handy ground wire sizing. I'm going to pick 1/3/0. The reason it does not populate with the size ground wire that you see there is because many times somebody will oversize their ground wire for different purposes. All right, if I want to know what size reel all this wire will go on, this information is for that purpose. Say I want to use a 320-foot reel with all those wires on there. That's going to give me a reel size of 40 inches by 27 inches, gross weight of 2375. That would be for one set of all those 5 wires. If I wanted 2 sets, I would simply change this to see my reel size, and for 2 sets, it would go on a 60-inch by 34-inch reel and be 4,770 pounds. And it would also exceed my Maxxis jacks. So this gives you information when you start stacking number of sets, what size payoff equipment you would need. Right now I'm just going to go back to 1 set and go with that. Okay, so next option I have once I enter my wire information is my conduit information. My raceway type, when I choose, it's the default is EMT for voltage drop purposes, but I do have a choice of PVC Schedule 40, PVC Schedule 80, flex, galvanized or aluminum rigid conduit, flex liquid tight, RTS fiberglass, IMC, or even cable tray. So it gives you all these options to calculate your tensions and sidewall pressure. So immediately when I populated this information, it immediately gave me the minimum size conduit I need per the NEC. Like I said, in yellows, the yellow sections, you have the ability to change that. Say you already had an existing 2.5-inch conduit, okay? It will still do the calculations for you, but it will still say minimum size conduit per NEC is 3-inch, and it gives you a little red error message here, exceeds minimum size per NEC. So this becomes an answer machine more than anything else. So just say if I had 3.5-inch conduit, it will give me my conduit fill information, gives me my conduit ID so I can check if I have something a little different than standard. But it also says minimum code still is 3-inch per code. I'm going to go back here and change this to 3-inch as it originally suggested. Okay, gives me a conduit fill of 33.318%. It'll also tell me my Maxxis grip size, type to use, and what size conduit I need to insert these grips on 500 copper THHN. I need a 3.5-inch conduit. So anyway, if I wanted to clear out everything that I did, I just hit clear all entries right there, but I don't need to do that. If I wanted to see a grip chart for all the different Maxxis grips we have, which are reusable grips, I can click that and get my grip chart. Okay, so now that we have our wire and our conduit type and size entered, now we're going to get tons of information that's automatically populating. First thing is I can get voltage drop. So this is the amperage at load per 1 set. Okay. System voltage, I can do single phase, 3-phase, and these are just suggested purposes. I need to put in exactly what I want. Circuit length, say I'm going to do 320 feet. Circuit length, just pop that in there, and it automatically gives me my voltage drop per NEC. Table 9 gives me my volts at load, very important. And it also suggests a power factor of 0.80. I can change that to a 0.90 if I like, and it will change my voltage drop information. Okay, I'm going to go back to a 0.80 and hit click and go from there. So I've got 2.3% voltage drop for 320 feet of size 500 copper in this case. Okay, most importantly, it gives me my volts at load. All right, next thing I want to do is it's going to show me my maximum pulling force for that cable, and south wire caps that at 10,000 pounds. The reason we do that is because most people don't have a tugger that'll pull more than 10,000 pounds. If I wanted to know what my maximum pulling force was for just one 500 copper wire, I could just click on this and change that to 1, change that to 0, change that to 0, and that will be my maximum pulling force for one 500 copper. At 4,000 pounds is when that cable begins to stretch. Okay, so I'm going to go back here and change this back to 3, then 1 neutral, then 1 ground wire. Okay, so that explains the maximum pulling force for the phase wires, for actually the entire cable pull in this case. The maximum sidewall pressure is a manufacturer default. We have ours set at 1,000 pounds. Before SIMpull came out, the industry standard was 500 pounds, but we have moved our suggested maximum sidewall pressure up to 1,000 using SIMpull. We also have jam probability. Jam probability is basically a bell curve. It's a numeric equation. Once I hit 3.62, that indicates very small likelihood of jamming. If this said significant, it's going to be red. You want to oversize your conduit to get the significant jam probability factor below significant. And I can tell you, in every case I've seen, when it says significant, the cables will get jammed. Okay, next thing we have here is phase wire ampacity considerations. Okay, this tells me what the limit is, withstand limit is for 500 copper is 102,415 amps, and that's for 4 cycles versus and a time frame of 0.066 seconds. I can change that if I like the drop bounds. I also have adjust for ambient temperature, 430 amps. I could adjust that if I wanted to change my drop down. I also have adjustment for current carrying conductors. So right now 500 copper is good for 430 amps at 9 degrees C. Well, we all know we can't use that ampacity unless we're derating, so we default to the NEC 310.15 at 380 amps. If I was using 4 current carrying conductors, try this again, 4 current carrying conductors, I would be at 344 amps per NEC, and that would actually change my value up top for my voltage drop calculations. Again, in purple, you got to change that. I'll change this back to 1 to 3 current carrying conductors, and I'm good there. The far column on the right top here is phase wire attributes. Let me explain that. That's these options here. Acceptable megaohm readings are 50 ohms to infinity is acceptable. Below 50 ohms is investigate, or call us for assistance. Gives you your dielectric constant for that insulation type. Gives you maximum temperature for dry use, wet use. Gives you minimum bend radius for that size cable. All of these are dependent on the cable size, type, and manufacturer. Okay. Minimum installation, minus 10 degrees C, 14 degrees Fahrenheit. Vertical support requirements or wire wedge have to be placed every 50 feet, or you have to have offsets, whatever. So Riser MC cable is a product Southwire makes that requires no vertical supports. Okay, so that's a consideration if you have very narrow chases. It also tells you the cable is sunlight resistant, CT rated, UL listed, doesn't have any NEMA information there. RoHS compliant. It gives you the temperature rating for 75 degrees C, 90 degrees C. Most important thing it does is gives you a coefficient of friction of a 0.14 for figuring cable pull tensions and sidewall pressures. It also gives you the stranding type of this particular wire for south wire, which is compressed soft copper class B. Okay, now we're going to move down and actually do a wire pull. So let's grab this and slide this down a little bit. So as you're doing your calculations, okay, everything in the middle of the page populates in bold because you'll be clicking different scenarios to see what you get. All right, so over here, this just reinforces maximum pulling force is 10,000 pounds, sidewall pressure is 1,000 pounds, very small likelihood of jam probability. All right, so you can change the configuration from complex to one of these others, okay, single, triangular, or cradle. We leave it at complex. It gives us a good conservative wire pull. You can change the coefficient of friction if you like. If you're not using SIMpull, you can raise that. I would never go below what that says. Incoming tension, you can increase or decrease that if you like. We set it at 25 pounds. And let me explain what incoming tension is. That's the amount of force required to get that reel, that wire to turn off of that reel as you're pulling it into the conduit. All of Southwire's payoff systems have steel rollers or ball bearings under that axle. Therefore, it only requires 25 pounds of effort to get all 4 of those phase wires and that ground wire on that one reel to turn off that reel. If I'm using jacks that do not have those steel rollers, you may have personnel turning it, and I don't know what your incoming tension would be then. Okay, maybe it will drop down to 0, I don't know. Or if you don't have personnel, that may be as high as 300 pounds per reel. So with Southwire's system, we keep the default at 25 pounds and nobody has to turn those reels. All right, so now that you understand that information, we're going to go into making a wire pull. All you need to do is populate the purple areas. The yellow areas automatically populate, or you can change them if you like. So we're going to say on this wire pull, I'm going to go up, feet to a 90-degree elbow. Okay, so let me explain. When I go this populated angular slope 90, when I set up, that assumes 90 degrees from horizontal going up into my gear and up into that conduit. That 10-foot length, that segment, is supposed to take me to the end of that 90-degree elbow. In the event I'm going out around a building 350 feet, 90 degrees, I would have to consider the entire 350 feet around that 90-degree bend as my segment length. If I'm in a building, it doesn't make too much difference, but that footage, segment length, is supposed to take me to the end of that 90-degree elbow. Okay. Also, when I clicked on 90 degree, I had the radius populate as standard. That's automatic default. I can change that if I wish. Most people use standard 90s in a building. So the next part of my segment, which would be segment 2 right here, I'm going to click horizontal. And we're going to go 30 feet. And we're going to go to another 90-degree elbow. Okay. And you'll notice the calculator knows what bend type and direction I need to set in there. If you're using Polywater's pull calculator, pull planner, you have to pick that. So if you ever get a difference in our tension and sidewall pressure, you can compare this to what you did in polywater, and usually that is where your error may have occurred. All right, so anyway, we're going horizontal 30 feet. The next segment, I'm going to go horizontal again, and this time I'm going to go 15.5 feet. This will figure it if you give it the information to another 90-degree bend. Okay, the next segment, I'm going to say I'm going to go up. And I'm going to go 10 feet to another 90-degree bend. Then in the next segment, I'm going to go horizontal, 30 feet again. And in this case, instead of a 90-degree bend, I'm going to have an offset. And say the offset has two 15-degree bends in it. I can do each one separately, all right, but I'll just combine them in this case and make it a 30-degree bend. Okay, standard radius offsets right there. All right, so just to let you know, you could do two separate segments, but I just combine that for simplification purposes. The next one, I'm going to go horizontal, 80 feet to another 90-degree bend. The next segment, I'm going to go horizontal, 90 feet to another 90-degree bend. Okay, and about this time, everybody's saying, "Oh, we got too many 90s. We have too many 90s." I want to go from one piece of equipment to the next, and I'll show you what we're going to do with these junction boxes here. The next segment, I'm going to go 12 feet to another 90-degree bend, and you'll notice I went red right here because it's continuously measuring my tension and sidewall pressure. The reason it went red is because it exceeded my maximum sidewall pressure for that type and size of cable. But I'm going to just keep going. I'll show you how to get the red out. I'm going to go horizontal again, 15 more feet. To another 90-degree bend. Okay, and then my last section, I'm going to go 10 feet down into my equipment, and there's no bend at the end of that, so that's it. So what I have here is it gives me all these red points because I exceeded sidewall pressure. Okay, what it also has done, it has also calculated my total length for this wire pull. Okay, and it's also put it up top here, and it has also put it up top in my circuit length. Keep in mind I already did that, so that's why it reads as 320, so it's actually going to be 302.5. And that is my real voltage drop for one set at that point. Okay, so we'll come back down. Whoops. Come up here a little bit. Okay, now we have a lot of things. All right, I'm going to, over here to the right, you can label your feeder name, origin, destination. I can put any notes in here that I would like. All right, so we have this red to get out. We have several options to do that. Typically, you might have a junction box here, which means I got a back feed in both directions. Might have a junction box here, And that means I would have to put another one here to make that wire pull, okay? I can't go any more than 360 degrees without having a junction box at some point. But what I would rather do to eliminate the risk of personal injury and damaging the wire is not have to backfeed through any junction boxes. I could change my radius of my elbow to, just say I'll pick 24 inch here, change them all to 24 inches, and we'll see if we can get the red out. And go back here. And that does not get the red out, okay? So what I want to do is then I'll pick the next most likely sweep I've got, which would be 36 inches, and make them all 36 inches. That way I don't have to worry about putting them in the wrong place. Last three elbows, if they're all 36 inches, when I'm green, I can pull all the way through from one piece of equipment to the next with all these 90-degree elbows. I do have to have a junction box after that fourth 90, after 360 degrees, but I want to put it in pull-through fashion. I don't want to use my pull box as a 90-degree elbow. When you used to have to lube cable, it made good sense to do that. You eliminated one point of stress, but if you can pull straight through, that is the smartest thing to do. All right, that's one thing I can do right there. Just change those elbows. All right, I'll go back to standard here. Go back to standard on the next one. Change them all three back to standard 90s. That's typically what is installed before you make a wire pull calculation. And I can hit this. I have a reverse pull button right here. If I hit that reverse pull button, yes, I would like to reverse it. Okay, it did decrease the amount of number of 90s I'd have to put in for standard or change my elbows. So it is easier to make the pull from the other direction. And if I labeled these pull segments, manholes or pieces of equipment, whatever I wanted to do, it would retain that information and tell you how to pull that. But I'm going to go back. I just want to show you that exists. Very handy feature. Yes, I want to reverse it back. Okay, so right now I'm seeing 318 pounds of tension. That's continuous tension. Actually, when you go through those 90s, you might see as much as 2,500 pounds more than that to get it through the 90. But once it goes through that 90, you're going to settle back down to this number right here. And like I say, these are conservative numbers. I'm going to now look at, so you saw option 1, change my elbows. Option 2, change my direction of pull. Option 3 may be to change my wire type to aluminum conductor. So if I change this to aluminum THHN, it'll automatically up my size because it knows what ampacity I'm looking for. Change that to aluminum THHN. Okay, so now I come down here. I only have to change this one elbow to probably a 24-inch sweep, and now I can make that pull a whole lot less tension. Okay, it automatically told me I needed to increase my conduit size for that purpose. It also automatically redid my voltage drop calculation for me. Okay, so by doing that, that's another function you can do. It also changed my reel size for me as well. All right, so I'm going to go back here and just go back to copper THHN like it was. Okay, so now we also have a show sketch button right here. I can hit this button, and of course you'll blow this up, but this, I'll change and do it right now. Go to 150%. This allows you to put your company logo in here, your name, your project name, all of this information that you would have populated will populate there. But this will give you a simple diagram of that particular wire pull. It's not to scale, but it gives you your tension and your sidewall pressure for all this information right here. So you can also print that out. Okay, now that we've done our wire pull, down here, and I am going to change these to 36-inch sweeps because I don't like red on my little chart. I'm sure you don't either. Okay. All right, so now we're good to make that pull. Over here to the right, it will actually show you what size tugger and what size rope you need to make for that wire pull. If that's red, I can't use that tugger. I use the Maxxis 6K with the 9/16" simple rope, or the Maxxis XD 10K with the 9/16 simple rope. You'll notice here it says continuous tension up to 3,500 pounds, but the tugger's rated for 6,000. Remember, I said you may have as much as 2,500 pounds of tension in that elbow. So if this number right here exceeded 3,500 pounds, we would move you to the next size tugger just to make sure that wire would not get hung up in that elbow for you. So next thing I have here is, some unique features that I can put in here. If I had a unique bend radius of 10.5 feet, I could put that there. And when I click on bend radius right in here, instead of standard, I have all these different bend radius. I got a 3-inch roller wheel right here, or a 6-inch roller wheel, or 9-inch radius roller wheel. Okay, if I click on UB1, you'll see that took my sidewall pressure down to 72 pounds because I changed my bend radius. Okay, if I had a unique degree of bend that I didn't see in here, okay, so just say instead of this being a 90-degree bend, I wanted a 80-degree bend, okay, and I don't see that in my list. If I go here and change this to 80 degrees, when I go to my list, degree of elbow, right in here, I would see now 80 at the bottom. I pick on that, and that again changed things again. Okay. If I had a unique slope that I did not see populated in here, just say I have a 35-degree slope. All right, I can change this angle of slope to 35 degrees. And now in my drop-down box, I will find 35 degrees, select it, and that changes everything again. Okay. If I have a unique bend radius going around a building, so this will determine my bend radius. Say the degree of bend is 90. Say the radius going around the building is 250 feet going through that 90. Try that again. 250. Hit enter. That will give me a radius of 159 feet. So in this one right here, just say that's where it was, I would put 159. And now it changed my unique bend radius 1 to 159. I have 4 pounds of sidewall pressure going around that 9-degree bend. Okay. So down here we have just basic information. Basically, you want your conduit system is assumed to be clean and free of debris. Otherwise, that's going to add to your tensions and sidewall pressure. Gives you how we consider the coefficient of frictions. 0.35 is for regular THHN, a 0.16 is for SIMpull X, a 0.14 is for SIMpull THHN, and that's also rated THWN. And there's no lube required for any of these calculations, any of these wire pulls. So that way you get consistent wire pulling, tensions, and sidewall pressure. Okay, so that pretty much concludes everything pertaining to the SIMpull Cable Pull Calculator Excel file. The app is a little bit different, so you just whatever you like best is what you will use. So if you have any questions, you can feel free to call me 770-378-3551. Again, my name is Alan Hooper with Southwire Company. Thank you.